So now I will explain more about the theory of our experiment. So first, what is Arduino? Arduino is an open source microcontroller which can be easily programmed, erased and reprogrammed at any instant of time. Second, Arduino is an open source computing platform that is used for constructing and programming electronic devices. And next, it is capable of acting as a mini computer just like other microcontrollers by taking inputs and controlling the output for a variety of electronics devices. And it is also capable of receiving and sending information over the internet with the help of various Arduino shields. So in our experiment, we use Arduino Uno, which is the microcontroller board based on the ATmega 328 datasheet. So in my slide, I show you the specification of the Arduino Uno, and it shows that the operating voltage was 5 volt, the input voltage was at range 7 until 12 volt, the input voltage, which is in bracket limits, is about 6 until 20 volt, the digital input output pins is 14, analog input pins is 6, direct current per input or output pin is about 40 ampere. And the clock speed of the Arduino Uno is 16 megahertz. So that is about the theory of our experiment. So next we will go to the procedure. Thank you.
So now I'm going to talk about the procedures of our experiment. So in the procedure, it must be considered the software and the hardware. So first of all, we need to read the instruction and get the guidance from the instructor or technicians. And then secondly, we need to prepare the hardware components such as circuit, breadboard, 12 DC motor with encoder, microcontroller Arduino, motor driver, voltage sensor and power supply. Then we need to make the proper connection wire between the components, and we need the guidance from the instructor about the connection between the components, and then we need to check the connection either function or not. So for the software, the Arduino IDE and MATLAB Simulink will be used to run the experiment. Firstly, we need to download the software from the official websites, and then we have to install the software with the requirement details. So firstly, the microcontroller real-time data acquisition, which is the software installation, we download the MATLAB software and the window installer, which is the Arduino IDE software at arduino.cc. For the microcontroller real-time data acquisition, which is the interface Arduino with MATLAB Simulink, there are two ways to interface Arduino with MATLAB Simulink, either by creating Simulink from installed Simulink support package or from installed Arduino input or output package. These two methods work in different manner. And then we use the Arduino input output package. So we downloaded the Arduino input and output package from MathWorks. We open the MATLAB and click on the add-on and search for the Arduino IO package, and then we download it. For uploading sketch, we uploaded the sketch adios.pte to Arduino through Integrated Development Environment software, which is the IDE, and then we click the file and open adios.pte. And then we check the connection, tools, board and port, and then we open the file, then upload it. For the package installation, we set the MATLAB directory to the location of the file install_arduino.m, and then we type the install_arduino at the MATLAB command line. So the experiment step-by-step procedure is, firstly we need to identify all the parameters for rollover, the ratio, sampling time and time response. The gain ratio for our DC motor is 21. So we choose the DC motor input constant interval of 150 revolution per minute. Then we set the running time for 20 seconds, and then we set to normal. If the mode count engage buffering, we have to set the upper and the lower limit. So the graph for actual voltage and scope must be saved with the x.mat files format. Then we just have to repeat a step for 175, 200, 225 and 250 revolution per minute, which is the RPM. So by using the 5 data set, we just have to compare the time response and overlapping, analyze and discuss the time frequency and stability.
So I would like to discuss our experiment, which is microcontroller in the real-time data execution. So we go to the table 3.0, which is data and speed of the DC motor. Okay, we just remind us data 1, 2, 3, 4, 5 is a data interval speed, which is data 1 150 rpm, data 2 175 rpm, data 3 200 rpm, and data 4 225 rpm. Actually, we have some technical problem, which is identify the speed of the motor DC. So for the data 5, we have 250 rpm. So we go to the actual voltage. In discussion, I just include the only three, which is actual voltage, scope, and scope 1. For the actual voltage, we just consider about the type of graph, which is a fluctuated, and we just analyze of the and amplitude. From the data 1, data 2, data 3, and data 4, we can conclude that the more speed is applied, the less fluctuated of the actual voltage. For example, if we see the data 1, we can see many of the fluctuated graph in the meantime of 20 seconds. For data 2 and data 3, it's become reduce, and we can see the data 5, which is 250 rpm, which is we have a low amplitude and low fluctuation. So that I can conclude that the more speed applied for the DC motor, so the less fluctuated of actual voltage. Okay, we go to the scope. For data 1, we can see that a little bit of amplitude, which is at the peak approximately to 515 amplitude at 6 seconds. They are fluctuated along the 20-second running time. Okay, when we go through the data 3, data 4, and data 5, we can see a lot of amplitude, a lot of fluctuation happen there. So I can conclude that the finding, the more speed is applied, the more fluctuated of scope. Yeah, okay. And the last is a scope 1. Scope 1, we can conclude that the data 1, data 2, data 3, and data 4, which is the running time is 220 seconds, we can conclude that all the graph have a inversely proportional like this. Okay, jadi for the data 1, we have a buffer. It's about 2 buffer, which is between 0 and 8. So the buffer, okay. When we go to the data 2, data 3, data 4, and data 5, we have a difference between the amplitude after 10 seconds. Okay, I mean that we can see the difference between the point to achieve negative 20 amplitude.
Our group has been ongoing about the experiment of microcontroller based on real-time data acquisition. And now I will give a conclusion about our experiment. From this experiment that we have ongoing, we have been able to achieve the object that to analyze the stability of DC motor that have the different parameter, and we have been observed about the different result that we have obtained, and the steady state error and transition response of controller by system that using MATLAB simulating software. Then we also have been able to solve the application in the control system by using the time and frequency response method in demonstrate analysis and design of physical system. Then the DC motor can be operate and at any intermediate speed by changing the voltage and armature current.
Then the open loop system has the control accuracy in speed that cannot be obtained in the speed that will not be constant for load vibration on the motor. So it doesn't have any feedback to the controller to indicate the change in speed due to the load. That's all. Thank you.